My name is Mary Napolitano, and I am the product manager for Adaptivo, as well as a medical physicist. So let's go over a bit of housekeeping before we get started. Today's webinar will be recorded. Please enter any questions at the end of the webinar. Well, you can enter any questions now, and I will address those questions at the end of the webinar. Standard Imaging is based in Middleton, Wisconsin, and was founded in 1989. At Standard Imaging, we design and manufacture a full suite of QA products. Standard Imaging is a green Tier 1 company. We have 3 solar panels in the rear of our office building, as well as geothermal heating. So I will provide a brief overview of the modules in Adaptivo. These are pre-treatment, during treatment 2D, which we refer to as in vivo, and during treatment 3D, which we call adaptive, the adaptive module. I will describe the tools within the software, and then I have a few cases to share later showing both the 2D, in vivo, and 3D adaptive modules. And then I will show the software for a bit so that you can see how we can use the 2D and 3D modules to assist clinical users in monitoring from the first to last fraction. So let's get started. The pre-treatment module uses a portal imager and verifies planned delivery compared to a predicted image. So this predicted image, as shown in this graphic, is collected without the couch or the patient in place, just for pre-treatment QA. It's based on a pre-configured gamma pass rate setup, and then based on that gamma pass rate setup, automatic notifications and results are generated. And of course, there is report generation as well. So the in vivo module uses daily EPID images acquired during the regular treatment sessions. The patient and the couch, as shown in this graphic, are between the beam and the imaging panel for the in vivo module for the daily exit image tracking. So this monitors the beam delivery as well as the patient position. The measured portal image is compared to the predicted exit image. So we have a predicted exit image. And then we also can compare the measured portal to a reference portal image. And typically this reference is fraction 1, but the user can select any fraction desired. For either of these 2 prior options, we perform a gamma analysis, and we show the signed gamma analysis so you can see which portions of the image are hot or cold. But this does not change the results in any way. It just gives the user an indication of the hot and cold regions in the plan. And then finally, we have automatic notification if deviation is detected, and of course, again, report generation. So most often, physicists focus on this module as detecting setup or delivery errors for a specific day. Clinics report increases in quality of day-to-day treatment setup because there is an independent method in place to check the setup. Then additional training can occur if issues are noticed for specific types of cases. And one can argue that just because there is a process that exists and is in place to check this daily variation, quality improves. This sort of usage improves treatment quality, or in cases where large and/or repeated misalignment is discovered, plan changes can be considered to compensate for the misalignment. In addition, trending and weekly average analysis may provide indication for triggering replanning, as well as just tracking to illustrate the types of available metrics. I have a few screenshots that I'd like to share. So some examples of tools within the software are shown here. So we have the daily and weekly gamma-based emails or dashboard alerts. And I wanted to talk a little bit about our dashboard. And our dashboard has gamma pass rate chiclets, pass, warn, and fail. But here I'm showing you what a chiclet is. So chiclets are these candy-covered gums, and our dashboard somewhat reflects those, because here are our dashboard chiclets, the green for pass, yellow for alert, and red, of course, for fail. And this is showing the treatment for 2 separate patients. And so your dashboard would have a much longer list. But just to give you the idea what the dashboard would look like, and it shows the predicted versus measure, or the measured versus measured gamma pass rate results, depending on which is flagging and alert. Next, we have some beam details. So here you can see that we have 4 different beams, beams 1 through 4, and then of course the fraction by fraction results. And each and every one of these beams and fractions, you see the gamma pass rate. And then you can open the plan up deeper to look at profiles as well as additional trending information. And I'm showing some of the trending information here. For example, this corresponds to the dashboard and plan results shown above. And you can see here for beams 3 and 4, the decrease in the trending. The next module, the adaptive module, was clearly built to focus on flagging when one should adapt the plan. A 3D dose analysis comparison compares the calculated dose based on the cone beam CT to the plan dose, both on a daily and cumulative basis. This is a fully automated system that detects when treatment has been delivered and performs a complete analysis. And this complete analysis is merged CT is created from the cone beam CT, with the planning CT filling in missing portions if necessary. The planning contours are deformed onto the cone beam CT, and which is actually the merged CT. The daily dose is calculated on the cone beam CT, and the inverse of the deformation is then used to map the daily dose back to the planning CT. And so then we can do this comparison either on a daily basis as well as a cumulative basis. As well, we have automatic analysis of DVH using the Quantec and RTOG protocols so that you can do your plan comparisons. And there's the clear and informative dashboard that I'll show you what the flags look like for that. We don't have the same sorts of chiclets. They're just a little bit different for the adaptive module so that you can differentiate the two. And then we have, of course, automatic notification of deviations as well. So in this case, for the adaptive module, we have these DVH-based active alerts, which are emails or messages. So these are just a list of what one should check. And then as well as these just text messages, we have some visual display of the DVH-based results for the plan, the daily, and the cumulative. So each of these colored circles designates the blue is for the plan. So the right parotid has no alerts for the plan comparisons, has one alert for the daily comparisons, and if you hover over it, it will tell you which fraction that is on, and one alert for the cumulative. And then similarly, the PTV has a cumulative alert as well as the PTV 63, while the left parotid only has a plan and daily alert. So one could click into this area, and I'll show you that later in the software demo, and it takes you right into the plan to start reviewing the DVHs. Then, of course, there are these details, which I referred to within the plan, the daily and the cumulative DVH, as well as ROI-specific trends. Here I'm showing a displacement trend, the fractions for the treatment session versus the size of the deviation. And then we also have volume-based trends showing the planned 100% volume versus the volume calculated during each fraction based on the merged CT and the warped ROIs. So patient bodies are not rigid, and so it's important to have visibility into the anatomical changes that are occurring between or during treatment. The anatomy may deform between or during treatment due to such things as tumor shrinkage, patient weight loss, etc. Variation from the planned dose may also be introduced from variability in the daily patient setup. All of these aspects must be considered relative to the cumulative dose over the course of treatment and, of course, impact your dose deposition. So the first case study I'd like to share with you is a lung and mediastinum case. This case was presented in more detail by Brian Pomager during a Standard Imaging sponsored webinar last summer. The recording should still be available on our website. Just look for the date June 2020. This case was evaluated using the in vivo module. One can see from the dashboard chiclets, which I've copy and pasted to the bottom of the slide, that for the first 30 fractions, the gamma pass rate has failed. Then starting on fraction 31, one can see that several daily alerts have occurred, and then a weekly failure followed by a weekly alert. And so then at that point in time, the physician was notified concerning these alerts. And before I go on, I just wanted to go ahead and show a bit more detail. So the area in this part of the slide corresponds to this portion of the dashboard summary. And so you can see this average is in this area, and then this is fraction 31 for the beams 1, 2, 3, and 4. And you can see that it's actually only beam 4 that has the alerts, but the dashboard shows alert if any of the beams have a gamma pass rate that is below what is set. And so here you can see, for example, the predicted versus measured profiles. If you look deeper into the plan, these are for fraction 35, that first failing fraction for ARC4. And so the ARC4 gamma map showed hotter areas, which is as well highlighted in these X and Y profile graphs. The red line shows the predicted in both graphs, whereas the green is the measure. These hotter dose regions show changes in patient anatomy, possibly due to weight loss and tumor regression. The original plan was discontinued, and after evaluation, a boost was added based on a new CT, which spared surrounding healthy tissue. The physician was able to increase the daily dose from 2.5 gray to 3 gray because of the smaller planning target volume on the new CT scan. And here's the next case that I'd like to go over in the slides before I get to the software. This is a lung plan where the patient was misaligned on fraction 18. The adaptive module showed the extent of the misalignment. With the registration, you can see today's tumor location versus the planned tumor location. And this is from one of our fraction viewers. And down at the bottom, you can see the fraction 18 dose. The deformed dose, deformed back onto the planned CT versus the planned dose. And you can see the differences here. And then going on for this case, the cumulative DVH, you can see the fraction 18 daily DVH, and you can see the difference here. And then as well, you can see the cumulative DVH and the variation, which is of course much less. The physician now has the information to determine whether this single day's misalignment will compromise the patient's overall treatment. The last case I'm going to share is, again, evaluated using the adaptive module. This is a head and neck case. As is common, the patient lost weight during treatment. The mask was poorly made, inconsistent daily setup, and the effects of these changes are tracked in Adaptivo. So here you can see some of the trending. This is the treatment number versus volume for the PTV, and you can see the decrease in volume. You can see a DVH difference between the planned and delivered cumulative doses as well. Again, in this case, Adaptivo provides the physician enough data to make informed treatment decisions. And so now I'm going to pull up the software so that I can review in some more detail what the software actually looks like. And hopefully you're seeing the software now. So this is what I refer to as the dashboard. And up here in the upper left, you see the active alerts for 3 of the patients that we have. Patient 7 has 7 alerts. I haven't been keeping up with my alerts because I'm not a real clinical physicist. Joe patient 3 has 2 and Joe patient 4 has 1. And then in this area, you can see some patients where we have the chiclets because we both have the in vivo as well as the adaptive dashboards combined. And so here you can select any of the chiclets to go in deeper for plan review, or you can select the ROI-based alerts and review the cumulative rule breakages for this particular plan or the daily differences. So by hovering over, you can see those differences as well. But what I'm going to do is I'm going to go directly into the active alerts for a particular patient, Joe 3, so that you can see what we would review further, because that's primarily the workflow for the physicist on a daily basis is coming in and checking the active alerts, and then of course reviewing at clinic-specific increments throughout the patient treatment. So let's go ahead and look at this fail region alert. And so we merely click here. And if I haven't been timed out, we should go directly into this patient plan a bit further. This is the failure. Here you can see with beam 1, we appear to have an alignment issue. And so I can go ahead and open up and review. This is the hot, cold gamma I was referring to, the hot region in red, cold region, of course, in blue, and you can clearly see the misalignment for fraction 1, beam 1. And then we can scroll on down and see the profile comparisons between the profile X and Y. and some additional gamma statistics and histograms that one can look at, as well as a variety of different views, as well as a relative view, which is not, of course, interesting for the first fraction, but is interesting for later fractions to review the fraction 1 versus fraction n measured portal images. So then let's go and look into a adaptive module case. The most interesting one we have here is one that shows failures from the in vivo module in fractions 9 and 36, as well as an average failure for the end of treatment. So since we've already gone in and looked at some in vivo analysis results, we'll go in and I'll just click into the PTV, and that will take us into the adaptive module results based on the cone beam CT. And so here we're taken directly to the daily DVH, and also the cumulative DVH is seen here. Right now you can see this is fraction 39, and we can go to the fraction 9 simply by selecting the dot along the bottom. You can see clearly that there is a variation between the planned PTV and the fraction 9 PTV in your DVH. And then we can see the same in fraction 36. A large difference occurs. Those alerts I was talking about can be reviewed further over here next to the PTV. I just have to open up, and you can see here the D95% on fraction, well, for the cumulative, the rule is that the DVH is within 10%, and in this case, the DVH exceeded that at about 14%. We as well can review for any of these cases the trending. For example, the PTV, we can go to the trending and look at the different trending. What's more interesting, though, is I will bring up the cumulative and the fraction viewers. This is the cumulative viewer. And so what we're looking at here is in the upper left is the registration between the planned CT and the merged CT. In the upper right, you can see the dose difference between the cumulative dose and the planned dose. In the lower right is the planned CT with the planned dose, and in the lower left is the cumulative deformed dose. And so you can see fairly good agreement. Of course, we can scroll through as desired to look through the plan and look in the different views, the transverse, the coronal, and sagittal. The next viewer is the fraction viewer. Here you can see that we are on fraction 3 right now. Again, in the upper left portion is the same. This is just showing the registration. The lower right, similarly, is the planned CT with the planned dose. The lower left is the planned CT with the deformed dose warped back. But the most interesting one is in the upper right quadrant. This one shows the deformed ROIs with the dashed line and the deformed dose as calculated on the merged CT. Of course, we can scroll through the different fractions. If you watch here, we're on fraction 3, and we're going to go ahead and scroll to fraction, let's see, which one was it? Fraction 9. There we go. And so you can see here clearly fraction 9, the deformed dose clearly is in a different region from the planning contours versus the plan over here. And of course, you can look through transverse coronal sagittal, and we could give a deeper look as well, and just step through all of the fractions, mostly focusing on the merged CT and the daily doses calculated on that merged CT versus the planning dose. And we'll get to fraction 36, which was the other fraction that was quite displaced. So with that, I'll go ahead and finish the presentation. So in summary, the first to last fraction monitoring using EPID images, the in vivo module, one can review repeated daily gamma analysis alerts, weekly alerts. We can further review using beam and fraction gamma pass rates, gamma maps, and profiles, and trends of the gamma pass rates by fraction for each beam. Fraction monitoring can be done using the cone beam CT image. Alerts based on daily and cumulative DVH changes are triggered depending on how you have your alert set up. To go deeper, you can go in and look at the trend plots for each ROI. You can review as well the planned daily and cumulative doses in 3D and the daily and cumulative DVHs, but primarily you depend in both of these cases on your automatic alerts to know when to look deeper into your plan. And so thank you for your time and attention. That concludes my presentation. Please type any questions into the dialog box if you haven't already, and I'll do my best to answer those. Sorry for the slight delay, and I hope the audio has been acceptable. I had to call in later. So let me see if I can get the questions opened up here. And I am not seeing any questions in the dialog box. So if I'm just missing them, please feel free to reach out to me individually at mnapolitano@standardimaging.com. And thank you for your time and attention.